Welcome. In this lesson, we're going to take a look at the effect of putting constructors in our superclasses and our subclasses. Let's get started. We've got two learning goals for today. The first is that we can add a constructor method both to a superclass and a subclass, but also explain the purpose of a new concept, the super reference, and use it to call a superclass constructor. Remember from the last lesson that inheritance is a relationship where one class, a subclass, inherits the variables and methods of another class called a superclass. So in this example, which is the same as the example from the previous lesson, we have a person superclass, and a person has a name and a birthday, and then we have a student subclass that inherits the name and the birthday, plus has its own data, a GPA, and a course schedule. We know that we can create a person object. Person, remember, is the superclass, and we can do that just by saying person P equals new person. And on the right, we see the object that it creates. Notice that the name and the birthday instance variables are null because we don't have anything to set them. But what if we wanted to initialize those instance variables when we make the object? And of course, the answer is that we can add a constructor method, which we've done before. And so I've gone ahead and added a constructor to the person class. You can see it's just a default constructor, no parameters. It sets the name to the word default and the birthday to 12/1. And because we have a default constructor, we can see that when we create a person object, person P equals new person, now the name and birthday are not null, but are set to their default values, because we know when we create an object, if we have a constructor, it gets automatically called. Creating this constructor in the superclass has an effect on the subclass. So on this slide, I make a new student object called S. And since a student is a person, creating a student object results in a call to the superclass constructor, because when I make a new student, I'm also making a new person. So you can see that when I make the student, it actually sets the name and birthday to the default values, again, because the superclass constructor is automatically called. Going back to the person class, the superclass, let's extend this example a little bit further. So before I had a default constructor, but perhaps I want a constructor that takes parameters. I don't just want to set the name and the birthday to like default values. I want to be able to specify. So this constructor now includes parameters, N for the name and B for the birthday, and it sets the instance variables accordingly. Now when we create a person object, we can send those values to the constructor, in this case Amy and 428, and we can see from the memory diagram that the values get initialized, not to null, not to their default values, but to the values specified by the parameters. The question then is, how does this affect the student? And this is the most important slide we've talked about so far, so really pay attention to this. Just as before, a student is a person. So when we call the student constructor, when we create a student object, the person constructor will also be called, but this time the person constructor has parameters. So let's see what happens. So when we say new student, it attempts to call the person constructor. The person constructor is expecting parameters, a name and a birthday, but we don't have any parameters to send it. And the result of this is an error. And so we need to deal with that. Maybe a viable answer is to just go ahead and give the student parameters when we make it. Maybe we can just say student S equals new student Amy and 428, right? Because the superclass constructor is expecting those values. But unfortunately, this doesn't work because if we look in the student class, there's no constructor to receive those parameters. In order to make this work then, we actually need to go ahead and create a constructor in the student class. Now, before, we didn't have any constructors at all. And when we just put a default constructor with no parameters in the superclass, we didn't really have to do anything with the student. But now that the superclass constructor is expecting parameters, we are now obligated to write a constructor in the subclass, in the student, so that we can go ahead and handle that name and that birthday. Now the student class itself doesn't really have anything to do with the name and the birthday. That's all from the superclass. So all we really need to do at this point is we need to pass the name and the birthday, right? That would be the Amy, the 428, N and B. We need to pass those to the person constructor. After all, it's the person constructor that's expecting them. So in an inheritance relationship, we have the ability to refer to the superclass using the word super. And so when I say super, I'm telling the constructor here in student to call the constructor of person, the superclass. And I'm sending that constructor exactly what it needs, the name and the birthday. And so this allows the code to now be wired up correctly so that it actually works. Let's summarize what we've done. So we're making a new student called S, whose name is Amy and whose birthday is 428. Since we're sending parameters to the new student, that means that the student class has to have a constructor. We have to have a place to receive those parameters, that name and the birthday. But the student class, which is the subclass, doesn't really deal with a name and a birthday. That's inherited from the superclass. And so the role of our constructor at this point needs to be to call the superclass constructor and pass along the name and the birthday. And it's that superclass constructor that initializes the values to Amy and 428, as you can see in the memory diagram on the right. So with all that in mind, let's ask a follow-up question. What if we wanted the other values of the object to be initialized as well? So we know that we're already initializing the name and the birthday. That's done in the superclass constructor. But what about the GPA and the schedule? Well, it turns out that that's easy because now that we have a constructor in the student class, we can just add on to it. Take a look. I'm in my student class. Again, it's the subclass. And notice that to the constructor, I've added two parameters. I still have the name and the birthday, but I also added one for the GPA and another for the schedule. And it's basically now has four parameters. Two of those parameters get passed up to the superclass for initialization. And now after that, the other two parameters get initialized here. So I handle the GPA and schedule instance variables here in the student class. The other values get passed right up to the superclass to get initialized. Now when I actually go to create a student object, you can see that I send the constructor four parameters. The first two are the parameters that are going to be passed on to the person constructor using super, and the second two parameters are the ones that are going to be only used in the student subclass. You can see the resulting memory diagram on the right, where the superclass has set the name and birthday, and the subclass student has set the GPA and the schedule. The awesome thing is that by using super, the subclass can pass any required information to the superclass. For our understanding check today, I've got 3 questions for you. So number 1, when are we required to write a constructor for a superclass? Number 2, when are we required to write a constructor for a subclass? And finally, can we write a constructor in a subclass without having to write one in the superclass? Take a few seconds, pause the video, think about these questions, and when you're ready, we'll go over the answers. When are we required to write a constructor in a superclass? Well, with the examples we've done so far, this is really never required, but we may want one to initialize instance variables. In a more complicated case where a superclass is also a subclass, where it's kind of in the middle of the hierarchy, there might be a requirement there as well. But the reason for that would go to question number 2. When are we required to write a constructor in a subclass? And the answer is that when a superclass constructor has parameters, the subclass must call the superclass constructor. So we saw that in our slides here, where we wanted to initialize some variables, and the subclass constructor calls the superclass constructor, and we have to have a way to send those parameters. Okay, number 3, can we write a constructor in a subclass without writing one in the superclass? And the answer is absolutely. A subclass might want to initialize an instance variable even if a superclass does not. So in this case, there's no need to use the word super because we don't need to call explicitly a constructor in the superclass that has parameters. All right, now that you've seen this lesson, you should be able to add a constructor method to superclasses and subclasses and also explain the purpose of the super reference and use it to call a superclass constructor.